Hey everyone! Thank you for joining us for the next episode of our Spotlight on GitHub Advanced Security series. My name is Anna. I'm your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view right here on the Microsoft Reactor channel. With that, I'd love to turn it over to our presenters for today. Lupita, Leonardo, thank you so much for joining.
Thank you so much.
Thanks, Anna. Welcome back, everybody, to our GHAS Reactor series. We are so excited to have you all here with us today. Remember, we like to make this as interactive as possible, so feel free to chime in where you are located. And then if there's any questions, comments, concerns, feel free to ask away, and we'll stop and answer as we go. For those of you who don't know, I'm Lupita. I'm an application security executive here at GitHub. I've been with GitHub for about 3 years. I was at Veracode before that and a software engineer before that. So I've been in the AppSec space my entire journey in the corporate world. And I'm excited to give you guys a little bit of insight on what's the latest and greatest within GitHub Advanced Security, which we now call GitHub Code Security, as well as Secret Protection. And with me is my favorite field security specialist, Leo.
Oh, I was like, Chad's not here, so I'm not sure who you're referring to. Hi, everyone. My name is Leonardo. I am what's known as a field security specialist here at GitHub. So my role here is to work on the technical aspects of advanced security, help customers understand how they can utilize advanced security to meet their application security needs. I've also been at GitHub for almost about 3 years. It'll be 3 years in February. And before that, like way before that, I was an English teacher. So that's quite the story of how I got to here. But that's not what this thing is about today. Today is about GitHub Code Security and GitHub Secret Protection. So let's go ahead and jump right in, Lupita.
Awesome. So for those of you who have tuned in with us in the past, you've probably noticed that a lot of these sessions involve an opportunity to learn about our technical alliance partners and what they do to sort of augment or provide certain things that we don't necessarily focus in on. And so we thought it'd be a good point in the series to kind of give you a refresher, an overview of what GitHub Advanced Security entails, the new latest and greatest updates, and then also what's coming. So many of you probably know that Universe is our biggest sort of event that we hold, and it is coming right up. So we want to kind of tease you on what to expect, and hopefully that gives you an opportunity to sign up and tune in. So let's talk about application security, right? In the age of AI. I know last week we got to learn a little bit about vibe coding and what some of our partners are doing in the space and how we can help developers think about security first. But I think sort of the big overarching why is this important is obviously because security debt is pervasive. We see that organizations continue to push applications to production simply because you have certain requirements to meet with features, functionalities, ensuring the experience of your customer aligns with their expectations. And so security can sometimes become an afterthought. And we know that that impact is not the greatest or most ideal series of events that could potentially occur when a breach happens. And so what we're trying to do is bridge that gap. And I know this is something that we continue to say, but how do we actually implement is what we're aiming to kind of highlight and show the new functionality that's available to security folks that aligns with developers' experience to make that more of a seamless integration between both parties. I'm sure you guys have seen this slide many of times, but I like to bring it up often because it kind of paints the picture of what we've seen with traditional application security testing tools. It's always kind of like bolted on, not built in. And what that causes is a lot of friction, right? Would you agree, Leo, when it comes to solutions? I know I came from Veracode, you came from Sneak. Oftentimes it's always, plug in at the end. It becomes inefficient to produce like a PDF report or an Excel sheet or tickets, and really having that native sort of integration in the developer's flow state is what intrigues developers to actually take action on things that could potentially be an impact.
Yeah, absolutely. I mean, more so Veracode than Sneak, since Sneak did try to integrate directly into GitHub and like kind of showcase in pull requests, for example, and do pull requests for dependencies and those updates. But traditionally, especially in larger enterprises that use tools such as Veracode that do a lot of the scanning after the fact, after the build, after developers have already pushed in their code, after that code has been promoted to a production or into a staging or into testing, the developers are going to receive a report at the end of that scan by the security team, and the security team is going to say, fix these. And so for developers, like, well, hey, we need to interpret what's in this PDF. We need to interpret what's in this report that we just received. And we need to be able to make changes, but not for this release, probably for the next release. Or if we're doing things more of like a waterfall type of environment, it'll have to be the next whole version of the software is going to include all of these different fixes. So depending on the types of cadences when we're actually building the software, at the end of the day, if you're giving reports to developers, you are really sort of hindering your ability to fix things at scale and at speed.
Right. Everyone wants to shift left though, right? But that's easier said than done. I always vouch and say that the cheapest flaw to fix is one that is simply never written. And as we know with Copilot, more secure suggestions are coming out of the solutions. But that being said, the human code that's being written still needs a form of verification, right? And so trust but verify, go fast but secure, have those solutions in place earlier in the process so that developers have what they need to succeed, to check not only the code that's being generated with AI, but also the code that they're writing in conjunction with it. So why do we do application security? I get this question a lot. It's because it's a native part of the experience, right? It builds trust internally, externally. There's an audit trail. It accelerates developer productivity. It's not fragmented. You have everything within a single pane of glass, and you can incorporate other solutions as well. I know from your experience, Leo, you mentioned Sneak had sort of an experience there. What would you say is sort of like the benefit of being a part of the platform?
Yeah, the big benefit is going to be getting developers the right information at the right time. So let's say, for example, at a pull request going from one branch to another, here are my changes. I want these changes to be a part of the main code base. Well, before we want to do that, we want to make sure that everything follows our standards as an organization. Part of those standards may be security. We don't want to have any critical or high vulnerabilities. So if we do have those vulnerabilities in that particular branch that we are trying to merge into another branch, that gives us the opportunity to fix those as a part of that pull request. So we can continuously update our code that we want to introduce. And so once we get to the code in a place that it is compliant with our organization's policies and security policies, we can go ahead and merge there. So it is the right information at the right time that is the most relevant for developers to take action on.
Exactly. And when we talk about what is in scope, from a built-in, not bolted-on perspective with GitHub Advanced Security, we're covering third-party dependencies right off the bat, anybody who's using GitHub in general, but then we go a step further and we do the code security testing, which is known as static analysis. We have the secret protection to ensure that we're providing an overview of any known secrets within the history of your code bases, but also preventing future leaks from occurring. And then having that ability to integrate other aspects of your SDLC scanning that occurs into a single pane vulnerability management overview. So now let's dive into this new concept of code security and secret protection. If you followed along, this makes it super easy to provide organizations the flexibility to turn on as needed the solutions in scope. Before it was just all bundled. Now it makes it easy to kind of pick and choose, especially if you have sort of different solutions that you're either working with for certain aspects of your overall application portfolio, or may be retiring some in the future and kind of want to have that ability to toggle up or down. But let's start with the reality of exposed secrets. We know that the fastest way to breach an application is through passwords. And the cost of not doing anything to protect yourself from that type of attack is extremely high. We think about like real world scenarios. Here are some examples of a large car manufacturer, a leading transportation platform, and what that looks like. And so again, when we think about the secrets are the keys to the kingdom, a single compromised secret gives immediate authenticated access to sensitive data, to systems. It enables lateral movement through infrastructure. And the risk is even amplified within open source. I had a friend recently call me to say that one of her developers accidentally cloned and copied company code into a personal account, and now they're dealing with that exposed secret. So that is more common than you think. And so accidentally pushing enterprise code containing secrets to personal repos is one of the things we're trying to assure that doesn't happen. So that being said, detection is important, but it's simply not enough. I know that when we think about our approach to this is push protection is designed to be an experience that doesn't require any manual intervention, any webhooks, any scripts, or sort of management of the team to ensure all developers are invoking that process. It's just a natural state. Because we know that when it comes to resource allocation, you usually have like 100 developers to like one security person, and or some ratio of that sort. So we want to ensure that alert overload is reduced, right? We're only focusing on things that actually could be real and have an impact. And that way the productivity continues for the developers without slowing them down. What is the hidden cost of remediation complexity? Any thoughts here, Leo, on what you've seen or how complex it is?
Yeah, I mean, if I have a secret that's in my code base, first of all, I have to understand what services is that attached to? What does that allow us to do? Who owns that secret? What permissions are associated with that secret? How closely tied is that particular token to our infrastructure? Is it something that is low risk, low impact, or does this have a huge blast radius? And then once I understand those things, now I have to see like, okay, well, then what's the best way for us to deal with this? Because even if we change this out from our code base, or if we remove it from our code base, how are we going to be dealing with secrets in the future? Or do we have a secret vault? Do we have a way to have some sort of governance over these types of secrets? There's a lot of sort of issues and problems that come along. It's not like a one person thing that can fix this. It's going to be a larger team effort, including security, including cloud, including owners of the services that those secrets are attached to, including those secret minters, and also developers who are utilizing data from those services or utilizing the cloud infrastructure from some of these services in order to host their applications. So it can be very complex, and it gets a lot more complex as you get closer to like cloud infrastructure and how these keys are associated with those different services in those cloud companies.
Indeed, I agree. So the power of proactive secret management is really the key to success, right? We want to prevent exposure from the start, reduce that attack surface, not even get into the possibility you have to do any payouts. And so in all, ensuring that your brand is protected is sort of the secret protection promise. So with that comes push protection. I think that's the biggest value add. And I think our system even now has the ability to give you an example of what the cost savings would be if you have push protection in place, which is super neat. Again, it's more of a way to help kind of build an understanding of what the value would be when trying to build a business case internally. So it's not exact to a T, but it does give you a starter point essentially. Um, I would say comprehensive coverage is the other piece to the puzzle that provides a ton of value for our customers. Ensuring that we have high detection accuracy really helps prioritize the remediation. As we saw, Leo mentioned all the steps and different resources needed to ensure revoking occurs or rotation, and that can be cumbersome and overwhelming, especially if you're new as a developer. So with push protection, I think that's going to be the lead domino to ensure success within an organization to avoid those costly remediation actions. Developer education, right? That immediate feedback, not having to wait on anybody or ask a security person or Google or even just use a Copilot to understand what to do. It kind of becomes a natural process of that flow state because there's no configuration required. It's just there and blocking when needed. Now, if for whatever reason there is a requirement to push that secret through, we do have that flexibility for managing those exceptions with maintaining control. So there will be an approval process, which helps ensure policy is applied. Right. So comprehensive coverage, we do the full Git history, all branches, historical commits, collaboration spaces, documentation, public sharing. And then there's 3 types of secrets we assess for: the generic secrets, the provider-specific patterns, and custom patterns. When it comes to our partnerships with the 150 service providers, one of the things I always get asked is, can we also validate if internal secrets can be done? So I'll let Leo chime in on that because I know that's a very common question. Right now, the way that the partnership works is what brings an additional value to just detecting, generic secrets or your own kind of custom secrets. So any thoughts on that?
So the question you're asking is in regards to validating like custom secrets that are unique to an organization?
Or how our partnership works with those 150 service providers, which I think is now increased as of last release. I saw several more providers having been included to the list.
Okay, yeah, I misunderstood what you're asking. So the way this is going to work is that we have agreements with each of these different partners, at least for the most part. And what we'll do is either we'll have like a secure API endpoint that we've agreed upon with that particular partner, and we will submit the secret to that API endpoint. And then we'll get a response back that will tell us, yes, this is valid and active, or no, this is invalid and not active. And if we can't get a result, or if we don't have that sort of agreement with a partner, we'll just say like, hey, this is possibly active, but we haven't been able to verify that. All this is an effort to help prioritize which secret patterns get revoked and rotated first, and then dealt with in a much more secure way for the new secret patterns that do come out.
Mm-hmm. Yep, that helps with prioritization, right? Having those validity checks, being able to, dismiss alerts if there is some sort of compensating control or need to continue. Right? We are built for enterprise scale. Like I said, there are solutions that say they can do a form of push protection, but that requires webhooks or scripts or manual intervention configuration. And so the idea here is, because it's native to GitHub, there's no additional tools or complex configurations. You enable it and within minutes. So it's super simple to scale on all your repos. And then there's those enterprise grade controls. Here's part of the secret scanning program and how those partnerships are formed. As mentioned, we've had some new partnerships recently be released, so that's exciting. Ultimately, the GitHub secret protection promise is prevention first, streamline remediation, and enhance developer productivity. If you haven't seen this already, I like to talk about it a lot because it gives you an overview of where you stand today. It's the secret assessment that is free self-serve opportunity for you to generate a high-level report of the secrets within your organization. It gives you the total number of secrets, public leaks, both if they're provider or generic. Doesn't go into the details. That's where you'll need to help drive urgency within your organization to turn the feature on to actually figure out how to fix those. But it at least gives you a snapshot. It's kind of like a security scorecard. Any questions on the secret piece?
Can we actually switch over to my screen so I can kind of showcase what this looks like in practice? Whoa, that was fast. Can we do that again? Like switch back to Lupita's? Okay, it's not that fast. And okay, and then back to me. Okay, cool. Now let's do it 3 more times. Okay, just kidding. All right. So first and foremost, let's just kind of talk about some of the features that we get with secret protection in GitHub. So what you're looking at right now is just sort of some example secrets that we have in here. And you can see, a couple of these have this tag that says public leak. What this is referring to is that some of these patterns have been found in a public space or in a public repository. And so that particular pattern is now available for anyone to be able to see in another place. And so these sort of pills allow you to say like, okay, the ones that are active and publicly leaked, we need to take care of those right away. If I look at more details about these, you'll see here that this is publicly leaked, but this is an inactive secret on github.com. So you can say like, oh, that's a lesser priority because even though this is leaked and out there, it's not going to give anyone access to anything. So it's okay for that to be out there. We've revoked and rotated this particular one so we can, ease up on this. So we can go ahead and close this as revoked if that's what we want to do. Anytime that you want to close things, you can also add a comment to say why you want to close this particular alert. But further down here, you can see for every secret pattern, so in this case, this particular GitHub personal access token, if it is available in multiple files, we'll show you all the files here in the alert. So then you're going to be able to see, where in your repository this thing exists. One thing that Lupita did talk a little bit about, hey, what happened here? Is going to be this concept called generic secrets. So generic secrets kind of fall in like 2 categories. The first category, let me go ahead and pull a different example. It's going to be 2 different categories. So one category is going to be what we call a non-provider token. So this will be HTTP bearer tokens, RSA tokens, SSH keys, GPG keys, MongoDB connection strings, database connection strings in general, those types of patterns that don't necessarily have a specific service provider attached to them, and they can be more general. And also these AI detected secrets that are, mixed upper lowercase characters, high entropy type of strings. We use AI to help identify these types of things and be able to show you in these places. Now, with generic secrets, obviously there's not like a service provider that we can easily query and ask them, hey, is this active? So if it's like a DB connection string, we can't check your database to see if this is an actual password that will work in it. So we're not going to have some of those features of like the validation. But this at least lets you know like, hey, there is a password that exists inside of my repository here. And so we need to be able to do something about this and handle secrets in a much more effective way. Now, what Lupita also talked about is going to be push protection. So let me go ahead and make this a little bit bigger. And so what I have here is a repository that I've cloned over from GitHub. And in here, I have a secrets.txt file here. So I have all these secrets here. So I've made this change. And I'm going to go ahead and add this change. So add secrets.txt. I'm going to add my commit. Here comes the secrets. Nope. Oh my goodness. All right, there we go. Just got to sign it with an SSH key. Now what I need to do is I'm going to push this code. Now, when I push this, I should get a response that says, I have secrets in this commit, recommit the code, or remove the secrets, recommit the code without them. So I'm going to get push origin main. And now what you see is that I just got push protected. Yeah, push protected, get some. So what this means is it found all of these different types of tokens inside of my secrets.txt file that I was trying to add here. And so I don't want these secrets in my repository, but let's say like I accidentally added these in here, or like these are test secrets potentially, and so I need to get this bypassed. I can go ahead and do that, or I can just clean these out from my code base and then resubmit my commit. So that way we have our changes without the additional risk of these particular secrets there. So in a nutshell, secret scanning helps protect us, but also lets us know where our secrets exist in the code base, in the Git history, and whether or not these are, and helps us prioritize based on whether they're active and they're publicly leaked. So that's a key thing. Now, just yesterday, imagine this. We did the reactor today, and just yesterday, there's like things that have changed. So imagine that. What we have here is this concept of a security campaign. So let me go ahead and go into my Octo demo. So a security campaign, there also exist campaigns for code scanning, which we'll talk about in a bit. But when we're talking about secret scanning, we also just yesterday released the ability to create a security campaign for secrets. So what a security campaign is, it's going to be a way for us to have security and developers collaborate together on taking on technical debt. And so we can take that big chunk of technical debt and then reduce it to a smaller campaign in which we have a timeline associated with these things. We have a way for us to monitor the work that's being done. And with code scanning, or code security rather, there's some AI features built in. For secret scanning, they don't have those same AI features, but the value here is for us to be able to collect specific secret types and say, we need to get these revoked and rotated as soon as possible. And then here are the ones we need you to work on. So I'm gonna go ahead and create one here from secret scanning filters. I'm gonna go ahead and add filter here. And so I can say, let's see, there's all these custom properties which will be associated with our repositories. And so if I want to group these secrets by a set of repositories that match this custom property, I could do that. But more importantly for me, I want to look at specific providers. So I want to look up all of my cloud providers and hit apply. And so now I have 1,217 different patterns here that are also available in multiple repositories. And a lot of them have been publicly leaked. This would be a bad campaign because that's 1,000 to 1,200 different alerts here. But this is also a very big type of organization. So what I also recommend is to reduce them by going by repositories that have your most critical public applications. That would be a way for you to help narrow down that scope to say, like, these are the things we need to make sure that we get rid of, or we rotate and make sure that they are no longer active. And we're also dealing with these in a secure manner by using a secret vault or some sort of secure secret service. So this is a brand new feature that just came out yesterday. I cannot stress how cool and fun it is that we can say firsthand in front of the entire world that, and this is not a blog post, it is on the blog post though. So if you want to read more about it, go to our blog or the changelog, which is such a weird thing to say in 2025. Like, go check out my blog. Who does that? They're just like, oh, check out my TikTok. I'm doing a dance in front of a security campaign. But yeah, like, we have more information there, not on TikTok, but on our blog. And check it out. Try it out. See what it's like. But let's go back to you, Lupita, and let's talk about some code security.
I love that. And I just linked the blog, so Anna will be able to put that on the screen for us. All right. So now that you got a gist of what secret protection is, how easy it is, and how awesome it does, or how awesome it is, let's talk about what the first party code analysis looks like. Code security, static analysis, all same thing, different names. I always say code security. In this space, the industry doesn't have a detection problem, it has a remediation problem. I know I sound like a broken record, but it is so important to realize that it's not just about finding flaws. It really does matter what happens next. The number of times Leo and I get on calls with customers where they're constantly comparing, solution A to solution B based on the number of findings. And they always
Every
want to
day.
hear that there's more. And it's like, how have you been scanning with the tool for X amount of years and still have 5,000 findings? Like, you would think there'd be a reduction in risk. And so I think it's important to kind of take a step back as an organization and define what the business is looking to achieve. Is it just a report card showing that things exist? Is it more so understanding what that risk looks like, developing a realistic risk tolerance, and then actually taking action and having metrics in place to showcase the reduction of what that impact could be? And so a lot of times it's more about checking the box. And I think for us, like, our philosophy and approach to this problem is ensuring that developers have what they need to succeed to ensure that they're fixing those findings.
I just want to say, just really quickly on that initial point that you said about like how often we're doing like these comparisons. It's my favorite part is when they say like, well, this tool, gives me more results than your tool. And like the natural question is like, well, what do you do with all of those results? Like, oh, we just put them in the backlog. It's like, okay, so you have all these detections, but you don't really have a plan on dealing with them. So you're just accepting the risk as opposed to remediating on that risk. So it's always an interesting conversation, but it is a different way of thinking. Let's think about remediation as opposed to just strictly detection.
Hmm. Well, and my favorite thing to go back to is what is actually happening when a static analysis is running, right? And I know I talked to you a little bit about the mathematics behind it, with there being an NP complete problem here, where that means there's no 1 + 1 = 2. There is no right answer yet. That might change with AI and all the new,
It might change tomorrow, and then we'll have to do another reactor. Like, hey, we just yesterday it came out.
Exactly. But as is today, as it stands, there's no way to actually compare apples to apples. What one solution does versus another. And so what it really has to come back to is what the business is hoping to achieve. And in certain cases, it is more noise. More noise is better, as they want to maybe produce a bigger problem that may or may not actually truly exist. Because as we know, developers don't want to go through sift and to the findings that may not actually be real.
Ain't no one got time for that.
Exactly. And others may be more like pressed for time and have audits coming up, really want to focus on reducing that risk, are more prone to, attackers, that sort of thing, financial institutions, healthcare, etc. And so that being said, let's talk about what our plan, our approach, our philosophy to this looks like. The challenges we see are obviously false positives, alert fatigue, having a context switch, having to manage the configuration, or understanding like what queries need to be used, etc. And then the actual remediation guidance. I'm thinking Stack Overflow, Google, or even like putting your IP into ChatGPT is a problem. So having that remediation in line, that is already curated, already been reviewed, and being produced by the same system and ecosystem that's helping you with the creation, storage, and deployment of code. So we become that control plane, have the one-stop shop for everything. So with that, trust but verify, go fast but secure. So as mentioned, Copilot is already producing or attempting to showcase suggestions that are far more secure than if you were to just copy and paste from like a generic ChatGPT or going on Stack Overflow or Google. But with that, we have a separate component to the actual piece of the puzzle, which is the remediation portion. This is not Copilot, the solution you use to generate the code. Copilot is actually just powering a lot of functionality within the GitHub platform, within the GitHub system. And for us, for GitHub Advanced Security, we have what is known as Copilot Autofix. And that is the functionality Leo was alluding to within the campaigns. Once you have sort of like the stage set for your developers to know what the priorities are, call it, remediating all sorts of vulnerabilities found that affect hitting OWASP top 10 compliance or something. Then you can use Autofix to go in there and remediate in bulk automatically. So that's sort of the biggest piece to the puzzle with Copilot Autofix. We have some fun stuff coming at Universe that we can't talk about here. I know me and Leo went back and forth on what that would look like, but we can at least give you sort of the vision, what we're hoping for. And then as you go along with our journey, you can see what actually takes place.
No promises. The product specifically said they are not going to make any promises, but we will have exciting things to announce at Universe. We're just making sure that we have those things ready to go on that day.
That's right. Yeah. So with code scanning, one of the things I like to talk about is, the differences in what you see with other solutions. Of course, we talked through that a little bit, but I think the biggest benefit here is that we have hundreds of native security rules created by GitHub that are transparent, that are publicly available for you to see. I found that in the past, someone would ask me if we covered a specific language with a different vendor, and we'd say yes, but if you looked under the hood, what was actually being analyzed, it was very basic. There was no real control flow, data flow, and semantic analysis that was occurring, which is why we take a little bit to, and when I say a little bit, it's a very complex problem we're solving. So it takes some time to add additional support for languages. And so again, there may be some sort of gaps in that space where we get questioned as to why we don't support X, Y, or Z. But that's where our collaboration is key. We have, that overall sort of community experience where there's open source solutions that may fulfill that gap. Or in certain cases where like mobile comes up as a question, I'll say, well, oftentimes we recommend keeping like the business logic on the back, on the APIs, on the server side code, not on the client side code, where you may have the opportunity to get some visibility. It's better to kind of make sure things are architected and designed in a way where the risk is really not on the front end. So there's different ways when thinking about code scanning and what CodeQL does to help you sort of understand where the risks are, how to fix them, and prioritize on the items that are most critical versus just going through and identifying all potential paths. Leo, I know we had a great customer call today where one of the users actually understood like the best fix location. And so anything else you want to add from a code scanning perspective that you think the audience would benefit from understanding the differences in how we scan versus what other solutions do?
I think there's another key point that's a little bit of a higher level over this, which is the difference between code scanning and CodeQL in this case, and what code security as a product is, right? So code security is just the name of the product. Code scanning is an element of that product. And what code scanning is essentially a way for you to upload Serif, which is static analysis results interchange format, to GitHub for you to see other static analysis tools and their alerts inside of GitHub alongside the code base. CodeQL is GitHub's static analysis tool that when it does its scan, it'll also output Serif and upload to code scanning for us to see everything there. But since CodeQL is a native part of GitHub, we also add on the Copilot Autofix and those ideas there. Now, to go back to a lower level to what Lupita is talking about in terms of like how is it that were different in terms of scanning. When we're talking about compiled languages, you could have it one or two ways. I'm just going to look at the code statically and then make some assumptions on what I see there. Or two, I'm going to go ahead and scan the binary and try to, go in reverse to see how things are built and then make some assumptions that way, because there's an nth amount of paths that you could take through a code base if you're looking at it from that direction. What CodeQL is going to do is it'll hook into the compiler. So it knows exactly what code is getting built at the build time, as well as any code that does get generated. We can also extract that code there. So think of like Java and Lombok, for example. And so from that perspective, when we do that scan hooking to the compiler, we will go ahead and take that code and convert it into data, put it into a database for us to be able to run what we call our queries. That's the QL portion of CodeQL, the query language, which will allow us to identify those paths and those patterns that are indicative of vulnerabilities in the code base. That also allows us to be very specific in writing these queries, and also to be much more accurate than somewhat of a generalized scan and making a lot of assumptions on the code bases that we're trying to scan. So in general, and this is a conversation we have with almost every single one of our customers that are coming from a legacy tool, we are going to have less results. But just because we have less results does not mean you are losing coverage. What it means is we are being much more methodical and focused on the types of vulnerabilities and the places we're looking for them. And also, they're more likely to be true positives than not. The idea of, let me just give you all severities and as many vulnerabilities as possible so you have full coverage of all the things, looks great from a security professional's perspective, because now I can adequately measure risk. But from a developer perspective, it doesn't make sense, because now I'm looking at 5,000 to 10,000 alerts from a specific scan, and I don't know what to do with all of them. Which ones do I fix first? How do I fix them? When do I fix them? How do I address this gigantic mass of alerts? Security people are not making those changes. Security people are thinking, okay, well, what other potential ways can we mitigate this risk by using additional tooling, firewalls, etc.? But from a developer perspective, if they have to make those fixes, which they will be making those fixes, how do they address them? So CodeQL is our answer to that sort of question, which is, how do we get security and developers to agree on what vulnerabilities are important and which ones are going to get remediated first? And so that's part of our story as well.
And with Autofix, we're seeing that suggestions are accepted in the PR at 45%. So that's helping reduce the median time to remediation. So that 60% reduction is insane, because like when you think about like the customer conversations we have where they still have 5,000 findings after using more robust solution per se for years is incredible. And so I think this was one of the biggest value adds that we've seen from a historical alerts perspective in reducing that actual time it takes. And we have some data here that actually shows the types of vulnerabilities that we're helping with. So like cross-site scripting, we're seeing up to 80% in reduction for MTTR, I'm sorry. So medium time to remediation, and up to 90% for SQL injection vulnerabilities. So that is pretty awesome. Here is just like a snapshot of it. We'll actually hand it over to Leo to showcase what that looks like. And then also bring back that concept of campaigns, which just helps burn security debt, because developers are twice more engaged when they have direction. So having that campaign to provide influence on what's most critical to the business helps with prioritization. And we're seeing that 55% of alerts and campaigns actually get remediated, which in comparison without campaigns is only about 10%. So I'll hand it over to you, Leo, so you can showcase this.
Cool. So as an example of CodeQL running in a pull request, which is where we are right now, what I want to know is, how do we see, what does that interaction look like, and how does Copilot Autofix work inside of this environment? So I've added some new code via a new branch, and I'm merging that branch into my main branch, which is what you can see here. And in it, I'm adding 3 new routes, and these routes have vulnerabilities. So what happens is CodeQL identifies the vulnerability. I can go ahead and look at the source to sync. So when the data comes in, is it tainted? Yes. And then where the data goes out. Did anything happen to that data before it left my code base, before it was executed in some format? Does it go to a database? Does it go back to the user? Does something else happen? Does it go to a different service and now we're sending bad data somewhere else? In this case, since we're doing uncontrolled data in a path expression, in this case, we are trying to open up a file, and the file name is something that the user provides to us. That means the user could provide anything they want to us. It doesn't really matter. It could be potentially malicious. And so at this point, you can see here that we are getting that file name from the request object, and then we're going to try to open that file. So we're actually going to do something with it. Well, that's prime for a vulnerability in this case. And so we see that source to sync, we understand that data flow, and then Copilot Autofix is going to provide us with an explanation on why this is important, as well as a way for us to deal with this particular issue. So a long time ago in static analysis land, it was really, really cool when someone had like a generic type of fix, like, oh, you could do something like this. And it was better when it was like in the language in which you were working, but it wasn't specific to the case in which you're working on. And it doesn't really understand the context, anything else around it. It was just a generalized example. In this case, we have a very specific way to fix this specific vulnerability in this specific code base. And so what I can do is I can, chat with my team, like, is this actually a good fix? Hey, security team, can you review this and let me know, this is actually, like, is this something that I should be doing? Or I can say, you know what, I understand this code. I've read the code. I'm going to go ahead and commit this code, and I'm going to add this to this pull request. And when we do that, we're going to go ahead and run CodeQL again. And if CodeQL no longer finds that vulnerability in this pull request, then the status will go from X to check, which means we can go ahead and move forward. And you'll see here that I've done this 3 other times in this particular pull request. I've gone ahead and I accepted some fixes. We've run the scan again, and it tells me that these things have been fixed, as in these vulnerabilities do not exist in this pull request. And if I come down here, I can see right there that we have 4 new alerts, including one critical severity vulnerability. So I can see that information in my pull request very easily. Now, if I want to start talking about existing alerts, because these are all alerts that were brought in from this PR, and we can actually act on them in the PR. But if I want to look at things from a historical perspective, I can go ahead and view those in my security tab and see which ones I have. In this case, I have 2 SQL injection vulnerabilities. So in this, there's also an ability that I can click a button that says, fix this, and it'll go ahead and generate an auto fix in this alert. And so from here, it's basically just creating some prepared statements for me for both of these potential SQL injections. I can go ahead and commit this to a new branch, do a pull request, and easily fix this very, very quickly. As a developer, I am just accepting what Copilot is providing me, or I can take this and I can add other things. I can add additional fixes. I can do something else. But now I have the thing that I need in order for me to start moving. I don't have to spend cycles thinking, how can I fix this vulnerability? Where do I start? This is where I start, and now I can continue going. I can remain in the flow as much as possible. But from a larger perspective, let's say, for example, let's go back into our security campaigns here. And if I just were to create a template one here, what you can see is that with code security, we have a couple of templates that you can use, such as the MITRE top 10 known exploitable vulnerabilities. And so if I select this, it'll show me a list of all the vulnerabilities that are associated with that particular list of vulnerabilities, the most exploited vulnerabilities on the web. And once I create this campaign, it'll go ahead and start applying auto fixes to each and every single one of these alerts that are eligible for auto fix. So if we look at an existing one here, you'll see that we have, you'll see that if I click into this bad boy, that they already have auto fixes here. And so I can go ahead and start committing these right away. So that's a key thing. So security campaigns for code security will implement or start the process of adding Copilot auto fixes to existing alerts. So here's the next question. How do I know these things work? Is anybody asking that question? No one in the chat? Fine. No one in the chat wants to ask this question. That's fine. I'll just answer it myself. It doesn't matter. So what I mean is, and this is going to be announced at Universe, think of it this way. Everyone's heard about agents, AI agents. AI agents are the new Skynet. They're going to kill us all. That's cool. Before they kill us all, they're going to check if the fixes that we are implementing actually fix the issue.
Mm-hmm.
And we can also, again, run CodeQL to verify that in a deterministic way. So there are some really exciting things that are coming out for code security. If you want to learn more, we've done a Microsoft Reactor on this very topic with Lupita there as well. And we've also had our VP of product, Marcelo, do a talk at MS Build about this very thing as well. So really exciting things to come at Universe. And yeah, definitely tune in because there's going to be announcements on code security. There's going to be announcements on secret scanning. There's going to be a whole bunch of announcements on Copilot, all of the things, because that's where GitHub is really heading. Copilot integrated in a lot of parts of the platform, not because AI is the cool new thing, but because AI gives us the capabilities to move significantly faster. And I think ultimately that's what we want to be able to do as an organization, as a company, not as GitHub, but as you all, the companies that are people that are out there. If you can increase your productivity and increase your output, that will translate over to increased revenue. And increased revenue means everybody makes more money. I don't know. I'm not an economist. I don't know how these things work. I'm just a guy wearing a red shirt on camera doing a Microsoft Reactor. But if you can innovate faster, you can do so much more with the limited time that we have. So think of it that way. It's not an evil thing. It's an opportunity.
Mm-hmm.
And I think that's the key thing. AI is an opportunity for us to be better at what it is that we do. Anyway, that's a soapbox I need to get off of. Excuse me. Okay, I'm off the soapbox. I'll hand it back to you, Lupita.
Awesome. So I think the key takeaway for today's session is the opportunity that Copilot is bringing to all facets of the GitHub platform, and us being that control plane to help you be able to actually remediate, go fast, build at scale. And so Autofix and campaigns is the better together story, and super exciting that we released campaigns for secret protection yesterday. It wasn't in the plans to showcase that, but as we know, roadmaps are always kind of penciled in and they go with the flow. So very excited to have shared this moment with you all today. I think from here, there's a couple other pieces to the puzzles, but I think what you want to kind of focus in on is that we're the command center for all things, that be code security, secret protection, dependencies. And the next step from here is ensuring that you're creating secure and high quality code by default. So there's some There's some cool stuff coming at Universe for code quality as well. So you'll want to chime in to learn more about that. All right. So next steps, if you haven't enabled code security in your environment, please do. And if you haven't started remediating with Copilot Autofix, also take action. As you know, this functionality is free on open source projects. So if you want to poke around with it in your personal space, feel free. Next session for Reactor, we're actually going to show how to roll this out in phased approaches. So if you have a large organization where you kind of already know how GitHub Advanced Security works in all facets, but now you actually want to put a plan and implementation, taking the guesswork out of rollout, you'll want to join us with Modus Create to learn more.
Oh man, this is an opportunity. Take the guesswork out of your gas work.
Yep, exactly.
Hey. This is why I'm all personality. That's all it is.
And I love it. We're here for it. All right. Thank you so much for joining. We'll see you in a couple weeks.
Thank you all so much for joining.
Thank you, everyone, for joining. Thank you, Lupita and Leonardo, for a great session. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can also find that link on the screen or in the chat. And we'll see you at the next one.